Hello, we are Team C8 Whiteboard Pal. I'm Jenny Yu and my teammates are Sebastian LaDuca and Zacchaeus Williams. For our application area, we were mainly interested in solving the problem of teaching remotely and doing remote learning without necessarily having the hardware to draw pictures and diagrams easily. Diagrams are a very helpful tool in learning, but it's not straightforward setting up the capability to draw them on all systems. Moreover, tablets and other drawing devices can be expensive and are not consistently integratable for every situation. Drawing with a mouse can also be hard and very uncomfortable. So we designed Whiteboard Pal. You can see a basic flowchart here. To start, we get input from the laptop's webcam frame and turn them into image frames, which are passed into the media pipe hand pose estimator and the canvas calculator. The hand pose estimator is able to give us hand pose landmarks, which we use in our gesture detection calculator to detect if a gesture is present or not, as well as where the index fingertip is located. Our canvas calculator takes those in, as well as keyboard inputs, and generates a mask that stores all the drawing information. This mask is applied onto our original frame, which is outputted into the virtual camera and into whatever video meeting software you happen to be using. For our completed project, you can find the C++ repo at the link above. We require that you are on a Linux machine of any distribution, whether that be Ubuntu, Mint, Arch, or any others, and your laptop needs to have a working webcam. You, in fact, don't need a GPU for Whiteboard Pal to make it more accessible to everyone. And for setup, there are a number of libraries that need to be installed first, and we have included scripts and commands to set them up, for example, for OpenCV. Afterwards, all that needs to be done is to build the repo and run the code. Keep in mind though that the initial build can take about 15 to 20 minutes, so make sure you have enough time for the initial setup. As for the features included in our final product, Whiteboard Pal is able to track the index fingertip and draws onto the webcam feed if the presence of a specific drawing gesture is detected. The gesture in question is the L hand gesture pictured on the right. We also have 3 different modes you can toggle between. There's free drawing, which is default, there is a line mode, and there is an eraser mode. You can change the mode via the toggle M key on your keyboard. You can also change the color of the drawing with the toggle key V, and you can select between a number of colors between red, green, white, and pink. When running, Whiteboard Pal will show up as a camera option on your video meeting platform and can be selected. Included on the right is a picture of what the interface will look like on Zoom. Next up, Sebastian will be explaining how we tested our project.
There are 2 categories of things that we're trying to measure. First, there's the performance-related stuff, like frame rate measured in frames per second and latency measured in milliseconds. In particular, we care that for the user, the FPS stays at 30, which more or less is the standard frame rate for video chat. If it's below 30, the video quality will seem bad. We measure frame rate by simply keeping track of instants in time at which the last 30 frames were sent to the virtual camera out from Whiteboard Pal, and at each step dividing 30 by the difference in time between the first and last frames in that 30 frame sequence. Latency from the user's perspective is defined from the moment the user moves their hand to the moment they see the corresponding mark on the Zoom feed. Now, we want to minimize this so that the system feels responsive. Instead, we measure latency as the delay between a camera frame being received by the webcam and the corresponding output frame being sent to the virtual camera. Why? Well, because we can't really measure when the user's hand moves, nor can we measure when the user sees the corresponding stroke. Furthermore, we don't really have much control over how fast the webcam input is or how fast the virtual camera is. So it doesn't really make sense for us to measure those things because we can't change and improve them. For hand gesture detection, measuring accuracy for our particular gesture is hard because we're using Google's hand pose estimator, which essentially gives us a list of XY coordinates for a set of points in the user's fingers and hands, and using that as the input to a gesture detection model. And we'd more or less need to collect our own data set for that. So for the most part, the evaluation is qualitative for this. We also tried a few different gestures too, just to see what the best options are. As for the results, performance-wise, our system is pretty good. It sits comfortably at FPS, and latency that we measure across all of the team members' computers which is typically faster on a CPU with more cores than one with less, but overall, in no case was it something that is more than even a tiny bit noticeable, which is good for something that's doing hand pose estimation entirely on CPU. However, it could be better. This is the easiest to use gesture that we were able to get to work best was the L hand gesture, but even then, it's not that great from a qualitative standpoint. During the design and build process, we made two primary trade-offs. The first was prioritizing latency over FPS. This is because if the FPS is above 30, it really doesn't provide the user any extra value. Zoom, Google Meet, and other video chats, and in addition to most consumer webcams, operate only at 30 FPS and not really above that. So beyond reaching 30 FPS, we don't really care about the frame rate. Luckily, our design decision to limit the number of stages in our computer vision pipeline worked out in this respect, because it allowed us to minimize our latency at 30 FPS. The other primary trade-off we made, quite frankly, is choosing development time over user experience. Yes, this is a user-facing product, and most of the value a user gets is from the UX, but getting everything to work together was a lot more time-consuming than expected. Combine that with deadlines that can't be changed, and we ended up having to sacrifice our plans for building a nice UX so that we could instead finish with something that works by the deadline.
Alright everyone, I'm going to teach you guys how to build and run Whiteboard Pal. So first off, you just want to run this build script. And so I decided to rebuild everything, so it's going to take a little bit longer, but I'll probably cut that out. It should take maybe a minute. You can probably look at the clock at the bottom and see how long it'll take. But first off, you just want to build it. It's a pretty simple script, and then I'm going to show you guys how to run it. Alright, so just finished building. Now I'm going to run it. The run command is this one. This is also on our GitHub, just like the build scripts. And so I'm going to run it. And it's alright. And so now you can see me. And I'll just give you like a simple demonstration of Whiteboard Pal. So all you have to do is like make a gesture and see. So now it's following my fingertip. It's noticing I'm making a gesture, and then it's drawing behind it. And then we also have like some different colors. So to toggle color, all you have to do is press V. You have a bunch of different colors. And so yeah. Then if you want to erase, there's a erase mode. Just enter that by pressing X. Then so see, it's noticing the gesture still, but it's not actually drawing because you don't want to have to draw all the time. Along with that, so I can switch modes again, and then there's another mode, it's line mode. So you see what it did is it noticed I was making a gesture. So notice that first point, and then after that, it's going to draw a line between there and when I end the gesture. So that's how you can get actually perfectly straight lines. And yeah, so that's pretty much it on how to use Whiteboard Pal. There's a build script, there's a run script. Everyone can pretty much like does itself as long as you get the GitHub repository we have set up. And along with that, we have all those instructions there as well. All right, thanks so much.